But before we close out this very broad conceptual chapter on potential interactions between humans and climate through the MIS-6 to MIS-1 stages, let's look at the Holocene. We will come back to the Holocene in much more detail in the next chapter when we focus much more on evolution of agriculture and domestication of animals as well. But this is always interesting to look at in terms of how humans began to influence climate and not just interact with climate during the Holocene. As we said, this has potentially the initial perturbation in climate and the loss of megafauna and resources for a hunter-gatherer kind of lifestyle into being forced to invent agriculture, and then the unintended consequences of agriculture leading to settled lifestyle, because if you want to rely on food production by domesticated crops and livestock, then you cannot be wandering around too much, even though there are nomadic pastoralists that are still around in various places as tribes and part of the modern society as well. So as we said, we don't know whether agriculture was tried and failed in the Pleistocene because of the harsh weather conditions, or it was not necessary because there was enough natural resources attained, site selections, diaspora migrations, etc., allowed humans to survive without agriculture, and then it became essential in the Holocene? Or was it that the relatively stable climate of Holocene made agriculture possible as opposed to the Pleistocene where it was not possible? So that question remains open, but looking at global historical land use area estimates for two periods, note the different y-axis here. So we're looking at the modern period since the Industrial Revolution, where human impacts took off, population growth became super exponential because of food availability, fertility rates going up. There are whole details about how settled life led to monogamous life, better family care, child care, increased fertility, increased population, and increased exploitation of resources, and increased food production, and so on and so forth. So if you go back to the mid-Holocene 6,000 years ago and look at millions of hectares in rain-fed other crops, so it's split into irrigated other crops, rain-fed rice, and irrigated rice, because rice now dominates, especially in parts of Asia, as a agricultural activity. So these are rain-fed other crops which were quite dominant from the beginning, of course, as crops got domesticated and agricultural activities went up. There were abandoned lands for various reasons at some point, or shifts to other crops, and that changed land use types, like reforestation during the Black Plague deaths, for example, and so on. So there is the rain-fed crops over this period. If you look more closely here over the more recent period, the same thing in millions of hectares, you see that the percentage of irrigated other crops like other cereals went up quite a bit, and rain-fed rice grew, but irrigated rice has taken off and has methane emissions and other issues that we talk about in the global warming context, which we will talk about in the last chapter as well. So here, looking at the same thing now in terms of grazing area for the same period 6,000 years ago to present, and the more recent time. More specifically, you can see that rangeland and pastureland, rangeland has grown steadily over this period with some blips. and pasture has grown quite a bit. If you zoom into the post 1700 period, you will see just how much the rangeland has increased relative to the increase of pasture land has increased relative to the rangeland. There have been various debates about whether this kind of grazing has had serious impacts, the most specific case being the drought that persisted over sub-Saharan Africa for multiple decades from the 1940s, I think, into the 1980s or 90s, and it was proposed that maybe overgrazing by humans caused desertification, but it turned out that actually global warming, ocean warming created by rich countries, industrial emissions and so on, was largely responsible for that drying and not the overgrazing as was proposed. Okay, so these are details that have to be looked at in the context of human activity on multiple scales and multiple, not just direct land use like before, but also greenhouse gas emissions and the impact of that on temperature, precipitation, especially extreme rainfall and desertification, crop losses and so on and so forth. Okay, so more specifically looking at a model, height 3.2 regional land uses gives a better sense when you look at different regions. So North America, Latin America, Europe, former USSR, Middle East and North Africa and Turkey, tropical Africa, and then China, South Asia, Southeast Asia and Pacific developed area. So the caption we can read before: historical land use estimates by region for irrigated and rain-fed rice and other crops, rangeland and pasture. Please note that rangeland and pasture distinction is purely an indication of intensity of use and not of the land use conversions involved. So that's the definition used here. So I won't go too much into the details, but it gives you a sense of how rain-fed other crops and irrigated other crops versus also rain-fed rice. So blue and green, dark green are the rain-fed, and there are irrigated rice and irrigated other crops in lighter blue and lighter green here. Okay. Not surprisingly, if you start at 2000 years before Common Era 1 and 2000 years into Common Era now, you will see that the rain-fed other crops and irrigated other crops, rain-fed rice in North America, rain-fed rice is not there, but irrigated other crops and pasture and rangeland dominate. In Latin America, it's somewhat similar, but even more area used. This is a major beef producing countries like Argentina and Brazil that probably dominate this. That also affects deforestation of Amazonia and so on. In Europe, you can see that rain-fed other crops and pasture have grown. Again, meat consumption affects these land use types significantly, and for whatever reason there is a bit of drop here. One can look at the details in the book, but I'm not going to go into it. Former USSR has become a dominant meat and wheat producer as well. Middle Africa, so you can see the different scales here. Europe also has a smaller area in terms of millions of hectares compared to the Americas and former USSR. Middle East, North Africa and Turkey also have grown, different areas of course, but here rangeland has grown quite a bit, even though rain-fed other crops have also grown. Tropical Africa, much more area, and again increase in rangeland and pasture land, remembering that it's the intensity of use that distinguishes these land use types. China, much larger area. South Asia, which includes Bangladesh, India, Pakistan, Nepal, and so on. Smaller regions, but rain-fed other crops and irrigated rice, right? This is irrigated other crops, sorry, and rice, irrigated and rain-fed have all grown so substantial increases over time. So industrial revolution, population increase have all gone hand in hand with agricultural impact in emissions and land use growing everywhere across the planet. Southeast Asia, again, rice consuming countries, and Pacific developed, which basically largely Australia, which is a massive rangeland expansion rangeland expansion as well. Okay, estimated populations by different people over different periods here. Of course, uncertainties will be higher. You can look at 10,000 years, so basically at the beginning of the Holocene into the modern period from Common Era 0, and you can see this is obviously in millions, so we are getting close to, by 1700s we were already at 700 million. So this super exponential increase happened a lot in the 20th century, with additional billions added in about 13 years, I think. But fertility rates and so on have all dropped in recent times, thanks to mainly the education of women. So we'll revisit some of these human impacts. So this is not so much human interaction with climate other than land use type changes related to population growth and agriculture, but we will revisit agricultural innovation in the next chapter in more details, and then move on to how what it means for human evolution in terms of climate and human evolution for the future, especially if emissions continue the way they are going right now, which I have discussed in great detail in other courses, but here we'll focus mostly on following the book, adding some details in terms of human evolution and climate. Okay.